Alright, hello students. Today we take topic of electricity forward. We'll be studying about the types of circuits today. Basically, two circuits we talk about. Series circuit. As you can see, all the resistors are placed one after the other in a series circuit. Whereas in a parallel circuit, you see the current diversifying or branching off to the different resistors in parallel circuit. It is very important to note that current flowing through the resistors is same in a series circuit, and the voltage tends to differ. Whereas in a parallel circuit, voltage remains the same, but different current flows through the various resistors. In series circuit, all resistors can be operated on a single switch, so there is a lot of convenience. With one switch, you can turn on hundreds of bulbs. Whereas in a parallel circuit, each resistor has to be operated separately. Voltage drop occurs in series circuit, so that is one of the disadvantages. There is no voltage drop in case of a parallel circuit. If one bulb gets fused in a series circuit, the entire circuit breaks. Whereas in a parallel circuit, if one device is not working, the others are not affected at all. For series circuit, the most common example that we know of is fairy lights or Diwali lights. And in the domestic wiring, we have all the circuits in parallel. So, we are going to learn about the derivation for a law of combination of resistances in series. Take a look at the circuit diagram. We have three resistances in series with one another. And I've already told you that the current flowing through all the resistors is the same because they are placed one after the other. But the voltage will be different across each resistor. So total voltage will be the sum of voltage across all the resistors. So we can say that V equals V1 plus V2 plus V3. And according to Ohm's law, we know that V equals IR. So V1 will be IR1, V2 would be IR2 and V3 would be IR3. Now putting the values in equation 1, we get IR equals IR1 plus IR2 plus IR3. Now cancelling I, what do we get? That total resistance will be the sum of all the individual resistances. So it's pretty easy to calculate the total resistance in the circuit. And next we take up the derivation for law of combination of resistances in parallel. When the resistances are connected in parallel, you can all see the current flowing through them is going to branch off. Each resistance, that is R1, R2 and R3 respectively will have current flowing through separate current flowing through them, and that can be measured with the help of emitters A1, A2 and A3. And when we have another emitter in the main circuit, we will see the readings of all these three will be equal to the total current flowing in the circuit. So as you all know that same voltage is present across all resistors but the current differs. So we can say that total current is the sum of current across the individual resistors. So I, that is the total current, would be I1 plus I2 plus I3. Now according to Ohm's law, I would be V by R. So that as per that, I1 would be V by R1, I2 would be V by R2 and I3 would be V by R3. Now putting the values in equation 1, we get V equals R equal to V by R1 plus V by R2 plus V by R3. Now taking V common, the total resistance, that is reciprocal of resistances in parallel, is sum of reciprocals of individual resistances, and that gives us the formula for calculating the total resistance in the parallel circuit. Very interesting fact in the parallel circuit is the total resistance, the value is always less than the smallest resistance in the circuit. That this information really helps us to calculate the MCQs which require very quick thinking. When you are calculating, always cross check and see that the total resistance in the parallel circuit should be less than the smallest resistance that is there in the circuit. The next topic that we take up is electric power. Power, you know, is the rate of doing work. So we can say that power is work done upon time taken. We can also say that power is energy consumed and time taken, because we can do work only equivalent to the energy that we have consumed. And the SI unit for measuring the power would be joule upon second, that is watt. Now power, if we say, is work done upon time taken, we can also derive the value for a work, that is we've already done in the previous lecture, that V is equal to W upon Q. From that I can also write W as, that is work done, as a product of voltage and charge. So putting these values here, so I get P is equal to V into Q upon T. But you all know that Q upon T equals I. So I can also write electric power as the product of voltage and current. So that's interesting, right? So if we put the value of V from Ohm's law, you all know that from Ohm's law, V equals I into R. So if I replace the value of V as IR, we get a new formula for electric power, that is I square R. So interestingly, we've got three formulas to calculate electric power. And now if I replace R from here, R as per Ohm's law will become V upon I. So if I am putting this value of R in the equation above, so we get the next formula for electric power, that is V square upon R. So you can see how many formulas can we have for calculating power. And when you are doing the numericals, you really have to read carefully what all is given in the question, and as per that question you will pick up the formula that will help you get the answer required. See, you just have to learn these formulas by heart, and they are fairly easy. Alright, so the last topic of the chapter is Joule's law of heating. This law we need to study to understand how the heating devices work. You know, in heating devices, all the electrical energy which is consumed is converted into heat, and we have a lot of such appliances in the daily use, such as electric iron, we have geyser, we have oven, we have room heaters. They all work on this, they are all called the devices which are converting electrical energy to heat energy. And in order to understand that, you also need to know that these devices use alloys, and these alloys, because of their high resistivity and high melting point, make the device last for a longer time. We never use a metal in these devices, because metal would get oxidized easily, and then we'll have to frequently change the elements of the iron or the heater or a geyser, whichever device we are using. Okay, coming back to electric power, we know that electric power is energy consumed on time taken. In the resistive circuits that we are talking about now, the energy consumed get changed into the heat. So heat gained is equal to electric power multiplied by time. And we can write electric power as P. We've already done in the I've already taught you that P can also be written as I square R. So I'm just putting the value of P as I square R, and this expression where heat gained by the device is directly proportional to the square of current flowing through it. It is directly proportional to the resistance of the conductor and the time for the flow of current. This relationship is known as Joule's law of heating. And electrical energy that we consume, it is used for billing purposes, and for that the formula would be power multiplied by time. Whenever we are calculating the energy consumed in the SI units, it is measured as joule, and power would be in watt and the time would be taken in seconds. But when we are talking about the commercial unit of energy, it is kilowatt hour, and 1 kilowatt equals 1000 watts and 1 hour will equal 3600 seconds. So 1 kilowatt hour would equal 3.6 into 10 raised to the power 6 joules. Thank you. And that was my dog in the background.